given a definite integral problem or an indefinite integral problem, again, we always want to start with the simplest cases possible. So first check to see if any of the simpler formulas and theorems that we introduced in Module 10 will work to come up with that result. If not, now we have a new tool. We can check to see if our problem fits the chain rule. If our problem fits the chain rule, we can look at identifying that interior function and making our substitution. Once we know how to make that substitution, then we need to discuss what that procedure is for coming up with our final result. So the first step is select a substitution that appears to simplify the problem. Again, typically that means identifying the interior function and then setting u equal to that function g of x. Then we want to express our problem in terms of u and du. So if we're replacing that original function with u, now all of our variables should change to u. There should be no more x's in the problem. And instead of dx at the end, which would indicate we're integrating with respect to x, that final statement should change to du to indicate that we're integrating with respect to this new variable. So if we've done all of our substitution correctly, there should be no more x and dx in our problem. The only letters that show up should be u and then du. Once we have our substitution taken care of and we've rewritten the problem, we want to evaluate the new integral. And typically what we'll see after we complete step 2 is we'll be down to a problem that now fits some of our basic properties. So we'll be integrating a simple power function, a simple exponential function, something that we do know how to integrate from the topics we covered in the last module. So we'll complete the integration, and then our final step will be to express our results in terms of the original variable. So in step 2, we rewrote this so that our function was in terms of u. In the last step, what we want to do is go back and anywhere we have a u, replace it with the original function that we substituted in. So our final answer then is going to be in terms of x if we're evaluating an indefinite integral. If we're evaluating a definite integral, which means we have the upper and lower bounds to evaluate it at. So the first thing we want to do then is replace u with that original function g of x that we swapped out, and then complete the part where we actually evaluate the function at the upper and lower bound, and then find that difference. So with indefinite integrals, the last step is just to swap u back for that original function. With definite integrals, we'll replace u with the original function we swapped out, and then we'll actually evaluate at those upper and lower bounds and find those differences. This process sounds a little vague when we just sort of map it out theoretically, but these are the steps we're going to walk through as we look at each of the different examples for this module.